We are exploring diffusion and osmosis. Think about cells in particular in that semi-permeable membrane each cell has around it, kind of like the gatekeeper, right? Kind of like if you think about a fence around a yard, it's going to let certain things in, keep certain things out, so semi-permeable. There are many molecules, like small gas molecules, for efficiency of the cell that can just diffuse across the semi-permeable membrane. And that's when solutes are moving from a higher concentration to a lower concentration. They follow a concentration gradient. Kind of like if you're in an elevator, a packed elevator, right? As soon as that door opens, everybody wants to get out and spread out. When you have osmosis, you are particularly thinking about water molecules crossing that semi-permeable membrane, and that's really important for cells to be very efficient in allowing water to cross, since water is so essential to movement of nutrients and waste as well. There are some terms that we're going to come across like hypotonic, hypertonic, isotonic. When I think of hypotonic, I think of hippo. Hippos live in water. I don't know, whatever helps you remember things. But a hypotonic solution has more water molecules than the solute dissolved in it or disassociated in it. When you think about hypertonic, you're going to think about a lot of something, right? If you're hyper, you have a lot of energy. So if you think about that, I think of it as, okay, I'm going to have a lot of solution. You could think of it as like when the adults in your life would always be like, oh, they're hyper because of sugar. You can think of it as that. Sugar is often a solute when we're talking about solutions. So more sugar or more solute, that's hypertonic solution. Molecules are always going to be crossing the semi-permeable membrane to try to reach a state of isotonic solution, so to be equal on either side. That's the natural homeostasis that a cell wants to reach. So when there is there's no more net movement across the membrane. It's just kind of it's still molecules are moving, but they maintain equality on both sides. That's going to be your isotonic solution.